Assalamu alaikum. Now, last time we discussed the first order linear differential equation. First form separable variable, second homogeneous, third non-homogeneous in two different cases. So today we discuss form number 4, exact differential equation or exact form. Form number 4, exact differential equation. Journal form m xy dx plus m xy dy is equal to 0 where capital M and capital N are function of xy and multiple of dx dy is equal to 0. So first of all, write equation in this standard form: function fxy then dx plus function fxy capital N dy is equal to 0. If equation is exact, in case partial m with respect to y, partial m with respect to x. Original equation 1 is exact form if satisfy this condition my is equal to n x. Then after satisfaction of this condition, find the solution. Solution consists of two parts. Part A, integral mxy dx is equal to fxy, consider y as constant. Partial integration, integrate all the expression of m with respect to x, consider y is constant, which is denoted by fxy. Then part B, integrate terms of n which are independent of x dy is equal to g of y. Integrate all terms of n which are independent of x. जिसमें x नहीं है उन तमाम टर्म को विद रिस्पेक्ट टू y इंटीग्रेट करना है इज इक्वल टू से g of y. Then final solution, sum of the two fxy g of y is equal to arbitrary constant is required solution. Again I repeat, first write the equation in standard form: function xy dx plus function of xy dy is equal to 0. Then multiplier of dx is capital M, multiplier of dy is capital N. Then consider partial derivative m with respect to y. Partial derivative m with respect to y means x as constant, and find partial derivative n with respect to x means y is constant. If this equality hold, it means the identification of fourth form exact differential equation. And how to find the solution, which consists of two parts. In part A, integrate all the terms of m with respect to x, keeping y as constant, which is denoted by fxy. Then consider part B, integrate only terms of n which are independent of x, means terms only involving in y with respect to y, say is equal to g of y. Then sum a plus b is equal to c arbitrary constant is our required solution. So we consider one example to understand the identification of fourth form and corresponding solution. For example, 4x cube y cube plus 1 upon x dx plus 3x4 y square minus 1 upon y dy is equal to 0. Now question already is in standard form, otherwise write the equation in standard form. So question already in standard form, so this is our capital M, means function of m xy, and this is our capital N. By comparing the general form, multiply dx m multiply dy n. Now find m of y. M of y, differentiate partially m with respect to y, consider x as constant with respect to y. 3, 4, 12, 3 multiply 4, 12 x cube y square plus 1 upon x, derivative 0 because differentiating with respect to y. Then partial n with respect to x, n is equal to 3x4 y square minus 1 upon y. Now differentiate with respect to x, consider y as constant. 4, 3, 12 x cube y square, derivative minus 1 upon y 0 because y is constant, differentiate with respect to x. Now observe m of y 12x cube y square, n of x 12x cube y square. Now originally equation, if you follow the first form, so this equation is not maintained the separable variable form, because you cannot consider x or y common or y cube consider as common. Shift to the multiple of dy, not possible. Similarly dy multiple function involved 3x4, so you cannot separate the variable. So form number 1 is failed. Second is the homogeneous. If you consider this equation in homogeneous form, dy by dx is equal to fxy, so fxy is not homogeneous function because of different degree. After substituting lambda is equal to lambda x, x is equal to lambda x, y is equal to lambda y, lambda is not eliminated, not considered as common, so function is not homogeneous. So you can consider a non-homogeneous form, but this is not our standard non-homogeneous form, because in non-homogeneous form we consider the expression of dx, multiplier of dx and dy with polynomial first degree expression, but here we involve the higher degree. X3 y3 means degree 6. So in general this equation considered as non-homogeneous differential equation but not match with our standard general form of non-homogeneous differential equation. So that is why equation identified by fourth form. So in the sequence I show the failure equation 1, failure equation of 2, failure equation of 3. That is why we try to solve by form number 4. So form number 4 is exact and equation already is in standard form. So first find capital M function of xy, capital N function of xy, then find the corresponding derivative, partial derivative and the equality hold because the same expression 12x cubed y square, 12x cubed y square. So you can write n with respect to y is equal to n with respect to x. So this equation is exact differential equation because the equality hold the identification of partial exact differential equation. Now after this solution, so again solution consists of two parts. So first find part A. So part A now part A, integrate all the terms of expression of n. 4x cubed y cubed 1 upon x dx. Consider y as constant. Integral with respect to x, so x4 upon 4. x4 upon 4 y cubed as constant and 1 upon x log x. So simplify, you can write x4 y cubed and log of x. Consider y as constant. So this is first part of the solution. Then part B. Now part B consists all the terms, integral of all the terms which is only involving with variable y. Integrate all the terms of n which are independent of x, जिसमें x नहीं है. So you cannot consider this first term because of involving x4. So consider only this term. If expression of n involving all the terms x, so part B solution is not performed because no term involving completely y or any term independent of x. So you consider only those terms which are independent of x. If no terms involving, so part B is not considered. So part A is our completely solution. Just part A fxy is equal to c. Now part B consider minus 1 upon y then dy. Integrate only terms of y with respect to y. So no term of x is understood x is constant and no question about the x. So just integrate minus ln y. Final result x4 y cubed log x log y is equal to c, or by using property of logarithm log x upon y is equal to c is our final solution. Now consider another example. Y multiply cos of the function sine y of the function y d of x sine of x multiply cos of y plus x dy is equal to 0. Now again follow the first form. Equation is not separable variable because you cannot separate sine y and y function with respect to dx, and the problem involving sine x and x, all the terms involving in trigonometry with respect to dy. Equation is not separable variable. Equation is not homogeneous because if you substituting y as lambda y and x lambda y involving as angle of the trigonometric function, and you cannot consider lambda as common from the trigonometric function. So if you write dy by dx is equal to fxy, fxy 100% non-homogeneous. So in general you can say non-homogeneous form, but in our standard situation the function must be in non-homogeneous situation, the multiplier of dx dy must be polynomial expression of degree 1, x power 1, y power 1 and so on. So this is not a standard non-homogeneous form. So we try to form number 4, exact equation already in standard form, say capital M and say capital N. Now differentiate M with respect to y, derivative y1 cos of x, derivative of sine cos of y, derivative of 1 plus 1. Then derivative 1 with respect to x, sine cos x, x1 cos y constant as it is, derivative x is 1. Now observe my is equal to nx. So equation is exact form. So again the equation is rectified by exact form. Now the solution. Part A, integrate all the terms of n with respect to x. So integrate with respect to x cos y, then sin x, integral of cos, then sin y constant, y constant with this x, just like 5, integrate 5 with respect to x, so 5x. So sin y is constant just like by x sin y. The integral of y is constant, just xy, because y treatment just like 5, 4, 3, 2, 1, x, y. This is our fxy. Now part B. Now consider expression of n. Sin x, function of x, x, all the terms involving x. So the part B is not performed because condition is not satisfied. integrate all the terms which are independent of x, but all the terms involving x. So part B is not performed. This is our final solution. Y cos x, y sin x, not cos, y sin x, x sin y plus xy is equal to C. So in these two situations, maybe questions will come as all the terms of n which are not independent of x, so we consider this part A our final solution. Now generally exact solution pattern is followed by the identification of partial derivatives, but may generally if we follow this like the separable variable homogeneous or the other situation by actual definition, for example x dy y dx is equal to 0. For example, this situation. Now this expression involving x dy by dx can write differential of xy is equal to 0. Find the function whose derivative is given to you. So left hand side completely expression as differential of this. So this is the basic meaning of the exact differential equation. If you can find the function after differentiation in the form of total derivative, and then the result is verified, then you can say this equation is exact differential equation, and you can also follow the solution just after integration. But this technique is not easy. Some writers follow such type of technique and they write 50-60 expression. So it is difficult to memorize 50-60 expression. If this expression, then this is the function. After differentiating, you get the expression. So just like antiderivative. So it is not possible to memorize all these expressions and then write the function and integrate and then solve. So we are not following such type of technique. The generally mathematicians follow the solution of the exact differential equation by first identification by using partial derivative, equality, if equality hold and the previous situations are failure, separable variable, homogeneous, non-homogeneous, then you follow exact. Or it is not necessary you follow from 1 to 4, you can direct hit by writing equation in general form and find m and n and find their derivative. If equality hold, then you direct solve by using exact differential form. Or in a solution pattern, generally if you are not practicing and you are not direct hit, then you follow the sequence, the first form, the second form, then third form. As the failure situation occur, then you follow the next form and so on. So I will give you some questions, practice problem corresponding to the exact form. All questions are the exact form. Maybe if question identified by homogeneous, so previous I said that equation may be solved by 2 or 3 form at the same time, depend upon the satisfaction of the condition. So you can follow the other form also. So I try to write all these equations are in exact form, but maybe solve by separable variable also. So, but here we solve all these equations by exact form, but after completing the topic, all the form, it is choice, you can solve by any form. So maybe one question solved by one student maintaining the separable variable form, or the second student solved by exact form. So it is possible only if differential equation satisfy the general form of separable variable form and also satisfy the exact differential form conditions. So you can solve by separable variable or the exact form. So write some questions. X y square dx dy y minus x square dx is equal to 0. This equation is not in standard form. Remember, dx come first and then dy. So first write this term, then plus. So this is our m and this is our n. Similarly, x exy 2y dy plus y exy dx is equal to 0. Second question also write in form such that first dy then second dx. So remember, first write the terms involving the multiplier of dx and second plus the terms involving the multiplier of dy. If the sign minus involving, so consider minus sign all the terms of multiplier of dx and dy, because negative involving with the expression of m and n. General form consists of m plus nx dy. Similarly, third, e power y plus 1 cos x dx plus dy power y sin x dy. Now this is already in standard form. Exponential y plus 1 multiply cos x exponential y sin x dy. This is completely multiplier of dx. The product form is n and this is n 4 1 plus log y dx plus 1 plus x upon y dy is equal to 0. Then question number 5, x plus y plus 1 dx, then x minus y square plus 3 dy is equal to 0. Now expression of n involve the constant term. So this constant term consider as function of x and function of y. So you can consider as solution part or not solution part because of integration involving with respect to terms independent of x. So consider these two terms are independent of x. Not consider the first term because of x. Consider this, integrate this with respect to y minus y3 upon 3. Consider this as function of y. Constant you can treat as function of y, say 3y power 0. So integration of this 3y. So constant term generally considered as function of y or as independent of x. So it's depend if you consider the part of the solution 3, the solution may consider as correct, and if you consider the not consider the part of the solution, then an answer will be considered as the correct answer. So it is you have a choice to consider the constant term as an integral part or not. So this is all about question 1 to 5 exact differential equation. Thank you.